When you're staying at a hotel, fumbling with your door keys has become a thing of the past. The key card bears no room number, so in a tired or weakened state, you can afford to leave it in the restaurant. If you've managed not to lose it, you swipe or insert it to unlock the handle and get in. Clever stuff. The metal case that contains the door lock's mechanical and electronic components is called the housing. To make the housing, they begin by melting zinc ingots at temperatures of around 390 degrees Celsius. Die casting machinery then injects the molten zinc into molds. Between injections, sprayers coat the empty mold cavities with a release agent, the industrial equivalent of greasing a baking pan. A built-in cooling system hardens the metal. Then a trimming die cuts off any excess zinc. Meanwhile, the electronic circuit board, the brain of the lock, takes shape. Aptly known as the pick and place machine, this machine picks up the 60 or so electronic components and places them in the right position on each board. This computer-guided machine installs 15,000 components every hour. Next, the boards undergo wave soldering. A mix of molten lead and tin surges up from underneath, fusing the components in place and creating electrical bonds. Then both sides of each circuit board get a coat of silicon-based sealant. This protects the components against the elements. Meanwhile, back at the housing, workers lubricate them with grease. Then apply what's called a sleeve bearing, a nylon bearing jacket that enables the handle to turn smoothly. Next comes the drive tube, onto which the lever will be assembled on the other side. There are several clutch components that link the lever to the latch. Swipe the right card, and they permit the latch to retract. After applying more lubricant, they install an override that enables the hotel to open the door with a key if for some reason the electronics malfunction. They fit the circuit board and connect it to the various parts it controls, such as the clutch motor. Now they close up the completed housing with a steel backplate. This protects the components inside from rusting. The last step is to insert a battery pack. It holds 3 standard AA batteries. The factory tests the lock using a test key card, because the lock isn't yet programmed to work with a specific card. That's done after installation. Elsewhere in the factory, they assemble the mortise, the part of the lock that goes inside the door. When you lock a door, the mortise's bolt comes out of the door's edge and fits into the hole of a receiving piece called a strike plate in the door frame. They close up the mortise with a back plate. This demonstration shows how they install the mortise in the door. Once it's in, they screw a decorative plate on top. And here's the handsome finished door, complete with electronic lock. Keycards have instructions on one side, a magnetic data strip on the other. They use a generic card to test every lock that comes off the production line. In the quality control lab, they subject each new design to several rigorous tests. They open and close 1 million times. They subject the lever, latch and lock to repeated impacts. They are brutal and abusive. They also test lock function in extreme temperatures. These electronic door locks come in several metal finishes plated over the zinc, and even in a painted finish that simulates wood.